Hi everyone, and welcome to the lecture on solid and hazardous waste, otherwise known as trash. So from the beginning of human time, humans have created waste of some kind. Early on, the waste was mostly very organic, containing carbon. The type of waste that we created has evolved as our civilization has evolved. So now it includes refined materials like paper and cloth and inorganic materials, ceramics and metals. And of course, now that we're highly industrialized, there's a complex mix of waste that's generated. Due to urbanization, there is a shortage of space to put all of our waste. In the early days of waste management, it was acceptable to just have open burn pits to burn all of your waste, and that's no longer acceptable. There's a pretty broad definition of waste. It's really things that are no longer of value, anything that you throw away. A lot of this can be influenced by cultural norms. For example, the latest fashion trends may dictate that the outfit, the clothing that you bought 3 years ago is no longer fashionable and that may get thrown away. There are three broad categories of solid waste in the United States, and each of them have their own laws and regulations. So we'll go through all of these separately. The first is municipal solid waste, and this is what we really consider as the household trash. In 2012, the solid waste consisted of paper. About a quarter of it was paper. There were also food scraps, yard trimmings. It's moving now that food scraps and yard trimmings and paper can be composted. There's also plastics, metals, rubber, leather, textiles, glass, wood, and other components. It's interesting to see that the average person generates about 4.4 pounds of waste each day. It's estimated that by 2025, 2.2 billion tons of waste will be generated each year. The amount of waste generated depends on your economic status. So low-income people will generate less waste than high-income societies. The lower income waste is usually more organic material and less consumer products and goods. There has been a steady increase in the waste per capita since 1960. This figure looks a little bit blurry on my computer, but you can also find this in finer detail in the text. But what you see that looking back from 1960 to 2012, you can see that you can see a steady rise in the waste that we've been generating. So we'll also talk about some special waste. This is not municipal solid waste and it's not hazardous. It's kind of somewhere in between. Special waste has separate regulations. So some of the examples of special waste include medical waste. These are things that could be potentially infectious, coming from hospitals and research labs. It's really important that this medical waste be handled in a special way to protect the sanitation workers, the people who are taking out the trash, from becoming infected with anything. Construction debris is regulated as special waste. There's a risk of drywall combining with water to create hydrogen sulfide gas. Asbestos has its own set of regulations. Asbestos is a fiber that's known to cause cancer. There's also a lot of mining waste. The volume of mining waste exceeds all other waste categories. Mining waste refers to extraction of metals, coal, or oil from our earth. This also includes fracking, which is a relatively new type of mining waste. There are regulations for mining waste, but there are federal and there are also state regulations. So some states have completely banned some mining waste. So by banning fracking, there's no allowed mining waste in New York. There's agricultural waste. This is especially problematic from CAFOs, the concentrated animal feeding operations, where there are hundreds or thousands of animals in a small facility. The animal waste can create a lot of air pollution. There's radioactive waste. Radioactive waste can fall into low-level waste, which can go into special landfills, or high-level waste. So high-level wastes include the byproducts of nuclear power plants. There's no long-term storage facility. There's no plan to store this high-level radioactive waste. These high-level radioactive wastes are temporarily stored in spent fuel ponds, or they're stored in dry cask storage. Sewage sludge is another special waste. So this is the end product that cities that have sewer systems will, all their waste goes to a sewage treatment plant where it's treated to remove the the pathogens. There's not a ton done to remove chemicals, and what's left over is sewage sludge. The disposal can vary depending on the hazardous components, but in some places, including Vermont, some types of sewage sludge are permitted to be applied to the land as a fertilizer. There's a lot of growing concern that these treatment technologies do not take out pharmaceuticals and personal care products. So, for example, caffeine and birth control are going to be present in any sewage sludge mixture. There are also contaminants such as PFOA, dioxins that our bodies simply can't break down and that do come out in our waste. So these products just simply get recycled back onto the soil. Electronic waste, or e-waste, is a growing problem. This is something that typically the United States sends to other countries, usually poorer countries, where the workers are willing to pick through used TVs, DVDs, VCRs. They're often exposing themselves to hazardous chemicals by pulling these things apart and looking for the very small amounts of valuable metals that they can sell. The definition of hazardous waste in the U.S. has there are two sort of definitions. One is that it's defined by a specific industrial use. So if you're using a specific industrial process, you may be regulated as hazardous waste. Alternatively, the waste can meet several one or more criteria of being ignitable, corrosive, reactive, or toxic. So there are U.S. laws and regulations in place to deal with waste. There's the Solid Waste Disposal Act of 1965. This authority was given to the U.S. Public Health Service to help states develop plans. There's RCRA, which is Resource Conservation and Recovery Act, which was passed in 1976. This gave EPA the authority to regulate solid and hazardous waste. And importantly, it required hazardous waste tracking from the point of generation to the point of treatment and disposal. The RCRA also required new construction standards for landfills. And you'll see today that many landfills predate 1976. So there are landfills that do not meet these construction standards, meaning they don't have a liner. So the leachate is not contained. There was also the CERCLA Act, which is also called Superfund. This was a response to some of the hazardous dump sites that were discovered across the country. Basically, it gave EPA the authority to designate the most contaminated sites and prioritize those for funding and cleanup. So what are the strategies to deal with solid waste? The best thing you can do is to avoid creating waste. That's something that you can see from one of the videos on the class notes. It's not very easy to do, so it could be a fun challenge to see if, in a week, can you avoid making any trash. So we know that it's not really feasible to just generate zero waste. So the next best thing is to instill the reduce, reuse, and recycle mantra. So less toxic materials have been used in industrial processes. There's often less plastic being used to make the milk cartons, so there's less material being put out into the consumer stream. This also includes using recyclable or reusable bags rather than getting new plastic bags every time you go shopping. Recycling is also an important one. You'll see in the next slide, recycling has increased dramatically in the past few decades. Sometimes life cycle analyses can help industry to identify potentially problematic waste streams. So looking at a chemical and a product from its cradle to grave, basically. The disposal strategies in the U.S., according to the EPA, about half of our municipal solid waste is put in the landfill. For hazardous waste, about 15% is put into the landfill. So about 13% are put into energy recovery units. About 13% get reused to collect better metals out of them. And about 10% of the hazardous waste goes to deep well or underground injection, where the brine is injected thousands of feet below the Earth's surface. This is just one of the graphs from the textbook. Again, it's a little bit fuzzy here, but you can refer back to the text and you can see that the total amount of waste that's recycled is increasing. It's increased dramatically since the 1960s. Although there are still places where there's no recycling. Every time I go visit my family down in Alabama and Tennessee, it's shocking that citywide recycling programs just simply don't exist. So waste treatment and disposal. What do we do with all of our waste? In high-income countries, we have taken a lot of steps to create better landfills. So they are sited in a location that's not going to affect people's homes and hopefully not affect groundwater. There's a lot of controls that are implemented. There's a great graphic in your textbook that shows how the landfills are built with liners and the leachate, the watery goo that comes out of the or that precipitates down to the bottom is extracted out and sent to a treatment plant. The methane is extracted out. There are also hazardous waste landfills which have similar controls in place. In some cases, things can be incinerated. Incineration is a very controlled process depending on time, temperature, and turbulence. Sometimes it can generate energy, but there are a lot of concerns for air pollution due to incineration. Deep well injection, I mentioned. It's when liquids are injected thousands of feet deep into the earth. They're theoretically injected away from aquifers so the groundwater wouldn't be affected. In low and middle income countries, open burning is still very common. This is where basically all of your trash gets put into a pit and it's burned. This contributes significantly to the global particulate air pollution and contributes to the mercury emissions as well as CO2. So the health concerns. There are 5 major health concerns that are identified from waste. So the first is infectious disease from poorly managed solid waste. So there can be a lot of pests that are happy to live near trash piles. There can also be mosquitoes in areas where water is pooling. Drinking water can be contaminated by all the waste. This is true from the mining waste as well as from the landfill waste. We often see that chemicals can travel very well in groundwater, and when there's any chemical contamination present, it will move very readily and contaminate drinking water. There's concern for landfill gas migration. So if the methane is not appropriately treated, it can build up in places and lead to explosions. This is a very serious risk. There's also concern for the leachate. There's concern for air pollution. Anytime something is being burned, chemicals are being emitted into the air. Some of these chemicals, like dioxins, do not ever break down. So when some dioxins when products are burned, dioxins get produced into the air. They then disseminate throughout the environment and they eventually precipitate. They then bioaccumulate in the food chain, and then we eat animals or animal products, and we're then exposed to these chemicals. So this is just a picture to end with. This is a trash can in New York City, so you can pick out how many recyclable items you can see, and hopefully now we all think more about our trash and where it goes.